All right, there we go. So, thank you all for waiting. I see a couple more people have joined. So, let's just get started and we'll let the rest enter when they get the time. So, welcome everybody. Good morning, good day, and good afternoon, depending on where around the world you're watching this from. We, of course, are here in the Netherlands, as always, to bring you this podcast or webinar, actually. So, this month's webinar will be highlighting and a chat with Timothy Lankau, who is the CEO of Hive3D Builders, who will introduce himself a little bit later. Of course, as always, I will be hosting this, and in the background we have Quintin, who will be moderating this webinar for us. So, um, like I said, this time we'll be having a chat with Timothy Lankau from Hive3D, who has been one of our partners in Texas. More about that later, but he's doing very well. So we'd love to give him a bit of a shout out and ask for his experience with this technology. As always, we do these webinars on demand, or we do them live actually, but they're also reviewable on demand, either via our website or via YouTube. Questions, if you have any questions, feel free to ask those in the chat. Myself, of course, can see the chat, but also our moderator, Quintin, will be keeping an eye on the chat to answer any questions during the webinar. If the question is a bit longer or more complicated, keep it for the end, because, of course, we will always close with a Q&A where you can ask me questions, but of course this time also Timothy. Subject of the next webinar will be our 10-year anniversary, which is very cool. Like a couple of you might know, next month we will celebrate our 10-year anniversary, so the webinar will be dedicated to that. And the month after that, we'll have a chat with Arkham Technologies, who's also a partner of ours. Content of this webinar, like I said, we'll be having a chat with Timothy Lankau from Hive. We will start with an introduction of Timothy. We call him Tim for short, everyone does. Of course, he will introduce his company. Then he will talk a little bit about the material that he's using for his project, which is not our material, but something that he has worked on with a local partner. After that, we will talk about his actual projects, so the ones that he has done, the one that he's currently doing, and the ones that he might or will be doing in the near future. And like I said, we'll close it off with a Q&A. So without further ado, let's bring Timothy on stage so he can talk a little bit about himself. Hi, Tim.
Great. Hello, how are you? Yeah. Hello, how are you?
I'm good. Thank you for being here. Let's get into it. Tell us a bit about yourself, Tim.
Well, I guess on a personal level, I guess I'm an attorney by trade from a while ago. I left full-time law practice 3 or 4 years ago to start my first company with a few friends of ours. That was a behavioral health company. It's done pretty well. That company, my deal with them was I would support them in starting that company if they supported me in starting this company, which is Hive3D. So we, I've been in and around construction, my whole life, and really wanted to figure out a way to do it better, more efficiently. We have always had a keen focus on housing issues here in Texas and the U.S. and came to the conclusion some time ago that the only way to change things as far as the issues we're having is to do something different, even if it was wrong. So I got very, doing the same and expecting it to solve things wasn't going to work anymore. Just the economics don't pencil anymore here.
Definition of insanity, right?
Right. Yeah. So I started working on the automation side probably 4 or 5 years ago. We built our own construction printer with a partner, printed a very big house with it. And then we're looking for an improved path forward a few years ago, and when we started working with CBay.
Yeah. The funny thing is, it's mentioned here as well. Your academic career, of course, started at Texas A&M University, which, funnily enough, currently has one of our printers as well for their research department. Then a bunch, like you just said, of other professional careers, and then you ended up actually starting up Hive3D to come up with a company that would actually solve the problem that you just spoke about, right? So tell us a bit about Hive3D itself.
So Hive3D
Well,
started a few years ago. We spent I spent a while kind of looking into automation, home building. Tried to gather as much information as I could about it, and this is about 2 years ago. Kind of came to the conclusion that there wasn't a ton of great information out there. The information that was out there was, coming from kind of biased sources, not in an evil way. It's just companies that were in the space, so it was hard to separate the reality from the fiction.
sure.
And so our determination was the only way to really figure out if it was possible to build homes this way at a cost savings, which is all we're really interested in, was to begin building them. So we launched the company at the same time we started building our first printer with our first partner, and building our first house. So that project was going to determine whether we saw a pathway to true cost savings. It was a successful project. So we decided there was, but there was lots of improvements that we could make, and that we still make every day. And so that's what led us into our next project, and now into our scaling phase, which we're have lots and lots of projects on our wait list, and we're scaling, buying more printers, continuing to innovate on the material side and the mixing side, to get to those new projects.
Yeah, we'll talk about all that in a bit, of course, about material, about your projects that you have. So I just saw we kind of skipped a poll. For the people that don't know, we will actually go back to the poll because I am interested. Quinton says, "Nah, it doesn't matter. I want to know this." Okay, go back to the poll because I'm quite curious how many people actually heard about you, Tim, or your company before this webinar. I don't know if the poll can actually be rerun.
Okay.
It can, perfect, because I'm very quite curious. Cool. So some people actually knew the company, didn't know you, the mastermind behind the operation. And while the poll is running, just
Mastermind is a very generous term. Thank you.
well,
I am a mind. I am a mind behind the.
yeah. But to be honest, I think it's great that you're like, well, this technology seems to make sense, but I don't trust the information that's out there. So why not just start a company, do a pilot project, see how it turns out, and find out for myself, which I think is an amazing reason and way to start up a company. And luckily, in this case, it turned out quite well for you, didn't it?
It is turning out well. That's yeah.
Cool. So for the poll, not a lot of people in this current webinar knew you or the company. So this is actually great for them to meet you like this. One person did, and two knew the company. So that's amazing. Thank you, guys. I was just very curious about that. So, of course, because I screwed up the order of slides, we do immediately have another poll. Apologies for that. But it's also an interesting one. And I think that after getting the answers to that, Tim, you might be able to share your thoughts on it as well. But what is your biggest doubt about 3D concrete printing? No doubts whatsoever. I love to hear that answer. Of course, the options are the cost of the printing, sustainability of the material, difficulty of the technique, no doubts whatsoever, and then other. And with other, of course, we would appreciate it if you could let us know in the chat so we can maybe talk about it a little bit. Difficulty of the technique, no one thinks it is that, so that's great to hear. Let's see. No doubts whatsoever. That's the best, of course. Sustainability of the material. Well, I know Tim has a very great answer to that one. And then the cost of printing, which of course always is the question: is it actually cheaper than traditional construction? So all of these topics we'll touch on in a bit. Perfect. Seems about an even spread between the options, so it's a good thing. We'll touch on all of them. Let's move on, because of course the material was one of the doubts that people had, but you have quite an interesting story about the material you used, don't you, Tim?
Sure. So we approached our kind of printing process from the material backwards. So rather than first look at the type of printer we were going to use or build, we first looked at the material we wanted to build with, because the limited information that we did have on cost savings in home printing was heavily dependent on the material that you were going to use. So there was, our internal analysis said that we could spend somewhere in the realm of $300 a cubic yard on material to capture some cost savings. That is the same analysis that the Kobod Perry people shared with me. They shared with me their economic breakdown of it. And so we needed to see if we could start from there and develop a group of technology that would work around that material. So the first house we printed with a mixture that was about half Portland cement, half just sand, some other aggregates, a bunch of additives, and then half of the cement content, which was about a 3-to-1, was a POSA slag with a company that we had partnered with. And that POSA slag was some people call it a geopolymer, some people call it other things, but it's basically a Roman style cement that's made from pozzolanic materials. We used fly ash. You can also make it with volcanic ash. And you take that volcanic ash and but fly ash is typically used as a cement additive. So it's usually used to extend kind of your cement content and used up to 20%. So we started with a 50%, and then we moved to a 100% POSA slag mix on our new home. So the advantage of the material are that it's cheap, it's stronger than your typical cement mix, and it has a good carbon reduction footprint. So
sorry to interrupt you, but all of this research and all of this that you had done on the material front was before you actually got in touch with us. It was on the old printer, or even before your previous printer, correct?
Correct. Well, we were in the middle of it. It's an iterative process with us. So, we had designed our first mix, and then we were considering moving to 100% POSA slag as we were speaking with CBay. So the first question we had when we were looking at partners to build our kind of version 2.0 printers was, was it going to work with the type of material that we were developing? We had an option to use a very fast set material, which works perfectly with CBay's system, because CBay's system is designed to use a very fast set material. So there was just a good fit on that regard. So the material that we currently use would not work with our old printer. It would also not work with probably most other printers on the market, because most other printers on the market are designed to print much more slowly, and they're designed with multiple hoppers. So just like the CBay material, there's maybe 45 seconds from the time you inject water into our material before it's hardened or beginning to harden. So you can't, a lot of the other printers on the market have a second hopper over the extruder where you gather material in there, and then it would all be set inside that second hopper.
Exactly. So, and that allows you to, of course, for some people might know that we actually print at about between 400 and 600 millimeters per second. I believe you are right around this speed still, right? With your own material, even though it's not our material, you're still capable of printing at those speeds, right?
Our printer printed that fast. Yeah, so it was, our printer had to slow down on corners and things like that. So that's about how fast it would get in a long straightaway, and then it would slow down to go around corners. The CBay, the robotic arm system just prints it different. It's a whole different system.
Yeah, true. The time from mixing to actual extrusion or printing is a lot shorter, of course. Yeah.
Right.
So, and then this material, of course, because there's a bit of information available, or not so much on what it is, but that it exists, right? Some articles have been posted. You've been in the media quite a bit. I know we've reposted it because it's amazing, right? It's lower carbon emissions, lower cost. It's pretty much amazing on every front, and it works with our printer. So we're most interested, of course. But I get a lot of requests worldwide, like, I need that material and your printer, get it to me. I'm in Australia. But there we run into an issue, right? Because it's based on locally sourced materials near you with a local partner, right? So unfortunately, shipping it from Texas to Australia doesn't make it very eco-friendly due to transportation, right? How do you see that this material being used worldwide? Is there a possibility? Should they find different partners locally? What are your thoughts on that?
Yeah, so and we've talked to a lot of people about trying to help institute a system like we have, and I think it's helpful to take a step back about what we do that's a little bit different. So we're mixing this material on site, so it's not a material that's made in a factory somewhere, and we have a partner that makes the primary feedstock for it, but we actually create the mixture and the material on site ourselves. The feedstocks can be locally sourced with the right partner. So if you wanted to use this material in Australia, and we're speaking with people in Australia that are CBay customers about trying to find a way to localize it there. It's frankly, I'm the holdup on that. There's only a few people in our company that know how to do this, and it's a big job to go over somewhere else and kind of recreate what we're doing here. And we're very stretched thin with getting through our current projects and all the projects we have coming and our capital raise. So it's been a little bit difficult for us to spend as much time as I would like, taking this elsewhere. But we will move forward with some of these potential partnerships with other folks. And really what you would have to do is set up a system for it. So you'd have to localize your supply chain. You would have to find the feedstocks you need locally, which are available. It's just a matter of getting a partner in that area to produce them.
Yeah.
And then you would have to create a mixing system that would allow you to mix them on the materials on site the way we do it. And then you have to train people to do it. So there's an art as well as a science to it with the on-site mixing. It's pretty challenging. I mean, I think it's something most people could learn. I think smart people can learn it. But we have specialized equipment. We have a computerized volumetric mixer that we've made changes to and changes to the software. So we have to help someone do that with a mixing truck, and then train their people to mix it. And the mix changes a little every day. It's weather changes. The feedstocks are not often super consistent. So it's a matter of making adjustments and dialing it in. We use a group of admixtures on site to kind of even things out. And those changes, there's sand contents changes. The aggregates are not going to be the same every time. So we'll, look at them under a microscope and try and figure out, if they're going to work, and if so, what adjustments do we have to make to the binders to make them work. So it's just a training process. And yes, it can be brought internationally. It's just something that has to, be worked through.
Exactly. So it's a work in progress, and of course, it's something that goes through you. There's all kinds of ways to get it internationally, but it's not order it and get it the next day. So in case needed, we of course have the Ciba Ready Mix, which is for our machine pretty much a one size fits all. The weather conditions, aggregate, stuff like that, we can adjust that quite easily. But then there is optimization to be had, right? Like you have with your material, which is of course amazing. Congratulations on that. So
yeah, and I would say that you know, the difficulty in some sense is kind of the point. The the economics that we strive for with this to get to those price points can preclude, as well as the carbon footprint, can preclude shipping a pre-mixed material just because of the weight of the sand and the aggregates you use in the material. So so part of, to get the cost as low as we do, you're just going to have to use very common local sand, basically, which costs usually $30 a cubic yard, and that's the bulk of your mix.
Yeah.
So you can capture those cost savings, then you just have to deal with the heartache and the headache of making it work every day.
Yeah, and then I see a quick question from Kevin in between. How can it be near carbon neutral when it's produced with fly ash from coal, also if you add additives? So I can quickly elaborate on this, but I believe we have the same way of thinking about this. So normally this fly ash would be waste product, right? So the CO2 emission, of course, you don't produce fly ash without CO2, but you don't produce it for the purpose of this mixture. It is being produced and you just use the waste stream, meaning that the carbon emissions are emitted for the actual process that produces the fly ash, and you just use it, right? It's not like you're producing fly ash to make this mixture. It's
Correct.
there.
So yeah, we don't produce the fly ash. Like I said, you can also use volcanic ash or other ashes, and so it is a recycled waste product. There's an argument that it's actually a carbon negative mix because if we don't use, for the particular plant that we take it from now, whatever we don't use, they bury in a disposal site. So, the carbon's already entrained, and we're recycling a product, which is why we get a carbon credit for that.
Yeah, which makes sense. I mean, recycled plastic, it's also not like you're not using plastic, it's just you're not using new plastic. So you're not emitting more CO2 than you would if you just put it in the ground, right?
Right. And the other carbon savings that we see is that regular cement uses a substance or a process called a clinker. And to produce that clinker, it takes enormous amounts of heat energy. And that's why cement has a pretty high carbon footprint, is through the clinker process. The processing with the fly ash that we use is all a cold process. So there's no heat involved in producing the material we do. So we take a recycled product, we get a carbon credit for the recycling, and then the refinement process of it uses very little heat. So it doesn't use a lot of energy in the refinement process.
Clear. That makes sense as well. So another question about the material itself. So also from Kevin, max aggregate size, one, and then the second one would be what's the strength of the material compared to regular premix, and then let's just keep it to compression strength before doing a deep dive into material characteristic, but just compression strength, which is common for concrete, right?
Sure. So as far as the aggregate size goes, that doesn't matter for the material. The material behaves very similar to a fast set cement, so you could use whatever aggregate size you would like to use. That's actually going to be limited by the mixing and pumping system that you're using. So, we find it easier to print with a mortar, which uses very little large aggregate, so it's mostly sand, almost all sand.
Yep.
Using the sand does reduce the strength a little bit, which you can compensate for by increasing the binder content. So what we currently print with tops out at about between 5,800 psi and 6,500 psi is what our testing currently shows on it. After 7 days, it's about 3,200 psi, and then over the course of the next 20 days or so, it gets another 3,000 psi in strength. So compared to just a regular, high strength concrete mix, it's usually in the 5,000s, so 5,000 to 5,500 psi. So it's a little bit stronger than a normal mix, a little bit stronger than a high strength mortar as well.
Yeah.
And we can increase or lower that strength based on how much binders you use. So if you were mixing it a 2.5 to 1, we can mix it a 2 to 1, and 2 to 1 will be stronger. At some point, it starts to clog hoses and things like that, so you have to dial it back.
Of course.
And that, just for context, for anyone that's not familiar with concrete strength, that's far stronger than what we would need for the way we build. We really need probably something over 2,500 psi for the current building system we use. So we have a big room to work with.
Sure. And then there's another follow-up question on that, and I will answer it for our material. Maybe you can enlighten us about your material. But compensating the loss of strength by increasing cement content equals shrinkage. So for us, one of the main benefits of our own material, the Cibe mortar, is that we don't have a lot, if any, expansion or shrinkage during the curing process of the material, which of course also causes our material not to crack while it's curing or after, which is a very big thing in 3D printing, of course, the cracking of concrete, not only in printing, but concrete in general. And we did quite a bit of work to actually make this material together with our partners to not make it expand or shrink to avoid cracking. How is that on your material? Because I don't see loads of cracks on your buildings as well, which usually happens if it expands and shrinks a lot, right?
Yeah, so when we first moved to the 100% posit slag, we had some cracking. It's not a structural issue with the way we build our houses, because we fill our walls solid with a different carbon-friendly concrete. But we had some cracking initially. We've been able to almost 100% eliminate the cracking by using some fibers. So we have some PLA fibers that we mix in now, and those fibers add strength, and they have pretty much eliminated the cracking.
Perfect. And then another question while we're on material. I know for our material, for example, we have the Cibe Power Pack, which is the cement, additive, stuff like that, and then aggregate, which is a 30 to 70 ratio. I see there's some interest to know your ratio. I don't know if you're willing to share that or if it's proprietary, but
no, I mean the ratio of sand to binders runs anywhere from 3 to 1 to 2.5 to 1, depending on how we're mixing it that day. So, yeah.
Gotcha. All right, and then I see some other questions, but I will keep the rest, if people don't mind, till the end. So please ask them again once we get to the Q&A. So we'll move on to the next subject, and then we can get to those questions at the end of the webinar, of course. Unless there's anything else you'd like to share about your material, I think we covered quite a bit. No,
it's good with me.
Oh, good. Perfect. So then, of course, we have another poll, which we always do. And we've answered a lot of questions, had quite an in-depth conversation about it, but I'm wondering what people think is the biggest advantage of Tim's Hive3D Builder's new material. I can guess a couple of them. Of course, it's increased sustainability, and then we have the lower cost, superior strength, or other. And then about the superior strength, because of course, our Cibe mortar, we calculate everything in megapascals, Newton per square millimeter. So I have to convert that to 40.
Yeah, I wouldn't know where to start. PSI, I think, is a US measurement for pounds per square inch.
Exactly. So looking at it, 40 MPa is 5,800 PSI. So you were about 5,000 psi, right? Or five or
No,
six?
we're about 6 to 6,500 psi.
Gotcha. So even a little bit more than our material itself.
A little bit
It's
more, but I would say that both those materials are way stronger than they need to be, only depending on what you're printing. Depending on what you're printing,
Yep.
we're we take a 10-inch thick wall, we print the outside of it, then we fill the inside with a foamed concrete that has about 12 to 1,300 psi. So it's a big, it's an 8-inch thick monolithic wall, and we're building 1 and 2 story houses with it. So it's I mean, it can support millions of pounds, and we're maybe supporting at most 60,000 pounds with a lab.
We should both be good, regardless of your material or our material. It's definitely
and compressive strength in concrete construction is never the issue. I mean, the concrete has an enormous ability to bear load as a matter of compression. The more difficult parts are the the lateral strength and the racking and the that kind of thing. So no matter what your concrete mix is, if you're building houses and not skyscrapers, your issue is not going to be with PSI or megapascals. It'll be with how you're bearing your lateral loads.
Exactly. So to answer the poll, most people think it's the low cost that is the biggest advantage, and I do agree. While we love sustainability, and like we said, it's super strong. Of course, the best case to introduce a more sustainable material is by actually making it financially viable, which your material definitely is in your case with all the local availability. So I would agree the cost is the biggest plus, right?
I think so. Yeah. I mean, if it were not for cost, it would be far easier to import C-bay mortar because it is more consistent. It's easier to use. It doesn't require our own system to mix it, and the mixing equipment that we use is expensive. I mean, we're using these big volumetric trucks. They're hundreds of thousands of dollars. But for what we're trying to do on the affordable housing side, it's, from what we can see economically, it's the only path forward to try and get the cost point under, we're at about $180 a cubic yard. So to get it down in that area opens up the economics of the projects that we can do.
Sure. All right. And then talk about the material. This material you don't use for fun, of course. You use it to actually build projects. So let's have a chat about the projects that you've done in the past, which I know the first one of those was not on a C-bay printer. So let's have a chat about this, and then we'll move on to the project you're currently working on and the ones that you have planned in the future.
Sure. So this is the first house we did with the printer that we built with another partner. With that printer, we're actually joint venturing a project in Dallas now with that printer. But we're pretty ambitious. We decided to build a big house with it. These pictures, all the pictures in this thing are way out of date, as well as on our website. We're about 8 months behind on doing any type of marketing or taking new pictures. This house is pretty much finished at this point. So, all the windows are in, and we're just doing some trim work and things like that. But the house is ready to be moved in pretty much. And so this was a big house. It took us a couple months to print it. The total project time, was probably around 13 or 14 months start to finish, which in this area that we built it, we also developed this subdivision that it's in, is not bad. So the custom builders in the subdivision, that is our subdivision, we have other builders in the subdivision, are all quoting clients 18 to 20 months to, for their build start to finish. So to get it done in 13 or 14 months, we're actually moving a little bit faster for similar products in the subdivision. And that included building a printer. So that, that was the bulk of the time. Yeah. The actual printing time was probably a few months, starting and stopping and things like that. And, it's a big house. It's 3,200 square feet, which from what I can see is I haven't seen any single family ones other than the one going up in Houston right now that are bigger than that. There are, I think, a couple multifamily ones that might be a little bit bigger in Europe, but and maybe Windsun in China has done some weird things, but no one really knows what they do.
Really knows about that.
Or whether it's propaganda, no one really knows. So I think right now it might be the biggest completed 3D printed house, single family in the world, but who knows?
I think I might agree with you. I think maybe our partner in New Zealand, he's doing quite a big one as well. I don't remember the exact square footage on that one, but that's not finished. So you definitely have the biggest finished one, and that's all, including actually making this printer with that partner. So that's very cool. I'm looking forward to seeing the images when it's done. But of course, you are a construction company and not a marketing company, and I know how incredibly busy you are, which of course for a construction company is a good thing. And for us at Siebe, it's a good thing that you're busy doing projects with our printer, which we might have a chat about next, because this is what you're working on right now, right? Also, a bit of a backlog on up-to-date pictures, but what can you tell us about this project?
So after we finished our first one, we moved pretty quickly into this project, and these are the projects where we moved from the 50% pasta slag to the 100% pasta slag, and we also moved to the Siebe printer for these. So these are 5 smaller houses. These are we have someone moving into one at the end of this week. So for like a medium-term rental, they're going to rent it for several months while they're in the area. For an event. So of the 5, we've got, and I'm going to have to go off camera for 2 seconds while I plug my computer in, but I'll keep talking. Of the 5 that we have printed there, 2 of them are near ready to move in. 1 will be moved in the end of this week, and the other 3 are in various stages of completion. We're hoping to have them all finished by the end of October.
Very cool. I'm excited. Looking forward to seeing that. Tim, can you tell us a little bit about the progress from the first house to the last one you're doing? Of course, for the people watching, you can see on the images to the left, you can quite clearly see that the building is divided, let's say 6 seconds in height, right, where the print had stopped and then moved on. And then on the image to the right, it looks like it's only divided in 3 different layer components. Can you have a quick chat about that?
Yeah. So yes. I'm sorry. Could you repeat that question? You were breaking up for just 1 second.
Yeah, sure. So you did one building, learned a lot, applied it to the next one, learned a lot, right, applied it to the next one, right? How was that evolution? What have you learned? What are you doing differently now? And then, of course, important question, how fast can you now build such a building? How many days of printing is such a building?
Sure, yeah. So we were actually kind of dialing in our new material as we went on these houses. So the first house, which is the one you see on the far left there, we actually mixed that material by hand. So it was not a fun process, but we were mixing that in a drum mixer with buckets and then printing it. And so, but we were doing that because we wanted to get the ratios right before we tried to mechanize it. And by the way, for some reason my video is not coming back on. I'm going to keep trying, but anyway. So there we go. Okay, good. So we mixed that one by hand, and then moving on to the other ones, we started using our volumetric mixer. So we had to kind of create that system and get that truck working. The nice thing about using that truck is we can load it up one time with material and sand, and it has enough to print 2 of these little houses or 1 normal sized house. So it helps kind of solve transportation issues, as well as mixing the material for us in a computerized way, which is a little bit more precise, and then getting it to the printer and delivering it to the printer. So,
Sure.
So that was a whole new system from house to house. And then we had to kind of conquer the cracking issue, which we did with some fibers. Process little adjustments we made to the process. So the last house we did, it took us about 3 days to print. It was like a 600 square foot 1-bedroom house. And then the 900 square foot 2-bedroom house took us about 5 days to print that one. So we now are able to move pretty quickly. And, hopefully on our next houses, they'll be a little bit bigger, but we'll continue to push the printing time down. We want to be able to do these in, 3 or 4 days for a good size house. And we have a good pathway to get there.
Very cool. So I'm super looking forward to seeing the images of the finished houses you're working on. And based on this project, you actually got quite a lot of interest in the region, right? Some investors and new projects in the pipeline that actually allowed you not to buy one, because of course we love the fact that you trusted us and you bought one of our printers. But based on that experience, you have ordered 4 more. So in the near future, beginning of next year, or in the throughout the next year, you'll be receiving 4 more printers. So you'll have 5 doing projects around Texas. Can you tell us a little bit about that? Your choice, why to go with these printers? Well, you must like them, and then of course the projects that you'll be working on next.
Sure. Yeah. So we have really, starting from the first house we did, there was quite a bit of interest generated, kind of nationally, but abroad as well, and in what we were doing, and that just started generating, projects and project leads, and now we have a wait list that's, over 300 projects at this point that have been somewhat vetted to various different degrees. Some of them are for hundreds of houses. Some of them are for one house. They're all different sizes and shapes and locations. And then of course we had to raise some investment to scale up a little bit. So we're just now closing on that next round at the end of this month. End of October is when we'll close on our kind of medium-term investment round to get new projects going. We're also, as part of that round, merging with kind of an innovative panelized builder that we were using for our roofs in a completely bolt together housing solution, so that after we print the houses, all the other elements of the house, the roofs, the windows, the window connections, all that's going to be prefabricated so it can be assembled together on site rapidly instead of using the traditional framing and things that we still use for our roofs. So those projects there's a lot of them in Texas. The ones we've chosen for next year, we'll be doing 20 houses in New Braunfels, Texas, which will be affordable houses for the area on a slightly higher end. So those will be in the low 300s, and we'll be doing 20 of them. We'll be doing 10 in Marfa, Texas, which will be in the mid 200s, getting more towards the affordable side in Marfa. We'll be doing 3 in Houston, which will be true affordable houses. These will probably be rentals, but we'll be building them in the low 2s, which is people can't buy houses in this area for that anymore. So that's a product that really doesn't exist on our market anymore. It's a house in the low 200s. So going forward, that's what we're focused on, is trying to hit those price points while mixing in some bigger custom projects like we've done in the past, just for the architecture and the fun of it, and and people that have more money than sense and want to build something crazy, we'll do some of that as well.
Right. There's always plenty of those around, right?
Right. Yeah.
Very cool, man. It's super good to hear. It's funny to think that I believe you took delivery of your first printer, CB printer. Correct me if I'm wrong, but it's early this year, right?
Yeah, I think we finally got it on site around February, so middle February. Then we had to get it moved from Houston to Round Top, which is an hour and a half away, and get set up out there. But the way we use the printer, we use it a little bit different than Seabay's. kind of normal process. So, we've made some modifications and things like that. That took a little while, as well as um, getting the material where we wanted it. And since then, we'll be, our first of those 5 will be moved in this week, and then the rest will be, in the next month or so. So we'll have 5 completed, and we want to just keep scaling and moving faster, and see if we can see if we can go to the moon. Who knows?
That's amazing, Tim. So within 1 year, you took delivery, did a couple of projects, got investments, and bought 4 more. That's I don't know what, but that sounds like quite a success story to me. So that's absolutely great. Congratulations on that.
Yeah, I mean, lots of challenges. I mean, moving from 1 to 4 is going to be a challenge. And moving from 4 to 100 is going to be a challenge. So we'll keep at it.
Of course, but at least you always have us on the back end to help you out wherever needed, training, design, stuff like that. So we work quite closely together, but you've been doing great on everything that you've done by yourself, actually. So you don't need our help that much by the looks of it. All right, that's absolutely great. I think we should go to the Q&A because we have around 10 minutes left. Before we do so, we will have a final poll. Of course, this is one for you, Tim. Let's see if we have some people here attending today that will be interested in having you and Hive3D builders printing their home or project. So, of course, we will. Yeah, that's a good one. No, because I live too far. Yes, very much so. Don't have anything that needs to be built as for now, but maybe later. No, because please type in chat. I think Tim would love to know that feedback as well. Oh, and of course, if you do, Tim, where can they reach you if they're interested? Of course, like you said, there's quite a wait list, but
yeah, we have a website, hive3dbuilders.com. We have an Instagram, Hive3D Builders. We have a TikTok, Hive3D Builders. So easiest way is probably just go to the website, and then we have an email there. I think my phone number is on there. People can always call me. Those are the easiest ways.
Cool. So I see Quentin has already put your website in the chat. So people that are interested, feel free to check out the website for Hive3D. Let's go to the Q&A because we have a couple of minutes left, and I can imagine there might be some people that have some questions right now. So if you do have any questions for either me or Tim or both of us, please feel free to ask them in the chat. I see that. Let's see if I can go back and see if there's any questions that I didn't answer yet. Sorry. Oh yeah, that's a very good one actually. Tim, for you, because I know the general answer, but for you specifically, any issues with the structures passing building code requirements?
No. So there's a couple. I can talk a lot about that. The way we build it, we fill our wall in solid with a foamed concrete, which is another process we've developed for our houses. And once you've done that, so we have rebar in there, rebar foundation ties, rebar bond beams on the top and the bottom, some steel support going across. So once that is done, then the wall system is pretty identical to a CMU or an ICF. So the code officials here, we have clearance in Colorado as well, which is a seismic zone, have been very comfortable with it. But you do have to work with them. And you certainly have to get everything pre-approved because you can't knock it down and change it as easily as you could a stick frame house. So we haven't had any issues, but we have had to meet with department officials and pre-clear what we're doing to make sure that they're okay with it.
Yeah, and that's also pretty much spot on the general answer that we at SIBA give. I always say this to customers: we try to keep the construction principle, the structural principle, as close to traditional reinforced concrete as possible, right? So you fill your entire wall or your entire cavity with this kind of aircrete, I think, like a foamcrete.
Yeah.
For us, we don't do the entire wall, but we do have square cavities where we can put rebar and fill with normal concrete to make a reinforced concrete column. and then we have a ring beam, a connecting ring beam at the top, which usually suffices for pretty much all building regulation across the world. Even, for example, in New Zealand, where the earthquake regulation or the earthquake requirements are quite high, we just make these cavities bigger, put in more rebar and concrete, and then you can certify it even in an earthquake zone. So it's great that that works for you as well. This is kind of a follow-up on that, not so much code related, but more how do the municipalities react to 3D concrete printing? Do they welcome it? What do you guys think in your area?
So the municipalities that we work with right now, our next project is going to be in Houston, are very welcoming to it. They will give us lots for free to build houses on, just if we can build them at a certain price point.
Yep.
Everyone, most cities struggle with housing. So if you can introduce a method that has the potential to bring lower cost housing to an area, they'll be very easy to work with. If you're building other things, I don't know, but for affordable housing, you'll have definitely an inside track with working with municipalities.
Very good. That's nice. And then I have another question from David. I might have some hassle with the pronunciation. Might slag be a good source for the Berzelius material?
For what type of material?
Can you see the chat?
Let me see here.
Yeah. If you open the chat to the right, it's the last question.
Might slag be a good source for? So coal slag, fly ash, coal slag are pretty similar. You have to have a partner that can refine it and kind of bring out the cementitious properties of whether it's your ash or your coal slag. Volcanic ash is possible as well. It's just a matter of finding a facility that can refine it.
Cool. And then a bit of a question of a while back, but one we didn't answer yet. How does this material perform thermally? And then I'm expecting it to be the insulative value, not so much the expansion and shrinkage under heat, but maybe that's something you can answer as well. But I believe
sure. So it performs just like cement thermally, so that it's not going to have a lot of thermal resistance to it, which is why we use the foamed concrete and the cavities. So for a mass wall under the International Building Code, depending on the type of climate you have, you need a much lower R value for a mass wall, which is what these are. If you're in a warm climate, if you're in a cold climate, you still need insulation or a lot of it. We're good either way because the foam concrete we have has an R value of about 2 per inch, and we're using between 6 and 9 inches of it. So that's what the cavity is for. The material itself has a lot of thermal mass to it, so you do get a mass wall effect, which will be fine in a warm climate. In a cold climate, it wouldn't really insulate much. All concretes are poor insulators. They're a fraction of an R per inch.
Cool. Makes sense. It's something I kind of expected, but that's good. And then we have a bit more in-depth questions about the slag use or the ash use. So refinery slag would then refer, I think, to blast furnace slag. I don't know if that's comparable to fly ash or coal ash or volcanic ash.
Yeah, I'm not sure. I don't know. I mean, I think you'd have to look at what's in it and see if it's comparable to fly ash or a coal slag.
Yeah, sorry, David. Both of us not absolutely sure this, so I don't want to give an answer that's half correct and half wrong. I might as well not give an answer. I don't know. Something to look into. Online program. Is there any online program I can access to learn the program required to use the machine? So yeah, let me give a quick overview of the machine. Of course, we at CBER, we have the software, the hardware, and the material, or in this case, Tim has the material himself. We have the slicer, which is our own slicer called Chisel, which is an add-on for Rhino. which is of course a 3D modeling software. This slicer then translates the model to slices, which then go into Artisan, which is also our software, which then talks to the robot to actually print it. We of course have courses on how to use our slicer, and this is of course also included in the training when you actually do buy a printer. Same training that Timothy has followed with his team at our facility in the Netherlands, which is possible and included in the printer. But you can also have it on site. Tim just chose not to. Are there online programs to learn how to use Rhino? Of course, but since it's not our program, we don't offer those courses. This is something that you can do outside of SIBA or outside of any 3D printing company. 3D modeling software have their own courses. So let me know. I hope that I hope that answers your question. Anything else for now? I see there's perfect. So I don't see any other questions that I didn't answer. I might have missed one. I don't think I did. Tim, anything else you would like to add, share with the people here? Maybe a bit of a cliffhanger of what you're up to next. Anything else you want to share?
No, I think we're good. If you're interested in the projects, we will make an effort in the next few months after we finish this project to actually update our website, so you'll have the new pictures and everything on there, and post a few things to LinkedIn, and there's always media if you Google us out there and something. So feel free to reach out if you have any questions directly. I'm always happy to speak with interested people.
Perfect. Well, you hear him, guys. If you're interested, you're definitely allowed to reach out to him via the website, give him a call, and definitely look up Hive3D builders on Google, because there's enough media, videos, articles about them to find if you're interested in the progress. For now, I would like to thank you, Tim, for being here, of course, and for being such an awesome partner and doing so well over there in Texas. Yourself, I'd like to thank everyone here for attending and for your questions. If you have any further questions for us at SciBee, for me specifically, please feel free to reach out via our contact form. The link is on the screen. I don't know if it's clickable. If not, then Quentin can also put it in the chat, but it's very easy to find on our website. And like we said, if you want to reach out to Tim, go to his website and you can reach out to him personally. Of course, we would love to see all of you at our next webinar as well, which is about our 10-year anniversary. And so if you're interested, you should be receiving an invitation or at least a link to that. So feel free to be there as well. For now, that's all for me. Thank you guys for being here. Tim, I'll speak to you at a later time. And for everyone, thank you for being here and see you next time.
Thank you, everyone.